to find the limit of the upper limit of sine over x to the power x. So when you look at this, the first thing we have to do is we have to drop down. So let's drop down, okay, right in green. So we drop down the power, which is 1 over x squared. So how do we drop down? We use the natural logarithm. So what is it about? Remember, natural logarithm of a to the power b is b natural logarithm of a. That is the rule that we want to use for that. So in other words, introduce the natural logarithm both sides. We introduce the natural logarithm to both sides. So what it will be is a natural logarithm of L is equals to natural logarithm of square bracket the limit of x approaches 0 to the power positive of sine x over x to the power 1 over x squared, like this. So remember that the natural logarithm is an operator that we can actually put it inside the limit. In other words, what am I saying? I am saying that if I have a limit, if I have a natural logarithm that has a limit of x approaches a certain value, let's say 0 of f of x, like this, I can write it as the limit x approaches to 0 of the natural logarithm of f of x. That's what I'm saying. So we use this rule now to work on our limit. So it's going to be natural logarithm of L is equals to the limit as x approaches to 0 of square brackets the natural logarithm of sine x over x to the power 1 over x squared. So here we are going to use this idea here. That's what we are going to do. So let's use that idea. We'll discover that it's going to be the limit as x approaches to 0. We are going to have 1 over x squared natural logarithm of sine x over x, like this. So that's what we are having now. So now we are going to, so let's expand sine. So we use a Taylor series, okay, Taylor series for expanding, or it's we can use, or it's Maclaurin series, but it's a Taylor series. Okay, as far as I know. So it's going to be sine x. What does it say? Sine x is equivalent to the sum from n equals to 0 to infinity of -1 to the power n, all divided by a 2n plus 1 factorial, x to the power 2n plus 1. So it will come up as x plus, or it's not plus, it's minus, because there's this phase shift. Minus, is it a phase shift? Yeah, it's oscillatory parameter, minus x cubed over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial plus on and on and on. You can actually see it deals with the odd numbers. The odd numbers, if you look at the pattern that is shown there, it's odd. So now let's put in for our sign. So it's going to be the limit as x approaches 0, or it's 1 over x squared, natural logarithm of bracket. So we are having x minus x cubed over 3 factorial plus x to the power 5 over 5 factorial minus x to the power 7 over 7 factorial plus on and on and on. All divided by, all divided by, it went overboard, all divided by x here. Now you can actually see that we can factor out the x. So it's a limit as x approaches to 0 of 1 over x squared, natural logarithm, let's put another square bracket. I love square brackets. Bracket 1 minus x squared now over 3 factorial plus x to the power 4 over 5 factorial minus x to the power 6 over 7 factorial plus like this, all over x here and another square bracket. So if you look very careful, we can cancel that. So what are we having now? What are we finally having? We have the limit. Limit as x approaches to 0 of what? 1 over x squared, natural logarithm of 1 minus x squared over 3 factorial plus x to the power 4 over 5 factorial minus x to the power 6 over 7 factorial plus on and on and on like this, right? So when we have that, we have to ignore the highest powers, okay? Yes, we have to ignore the highest powers. So let's ignore the highest power. So we ignore the higher power. Higher power, that is x to the power 4 over x over 5 factorial minus x to the power 6 over 7 factorial plus on and on and on. This is what we ignore. So when we ignore that, what are we saying? Limit as x approaches to 0 is gonna be 1 over x squared, a natural logarithm of 1 minus x squared over 3 factorial. There we have there. So if we expand it, it's going to be limit x approaches to 0. Let's expand it. 1 over x squared natural logarithm of 1 minus 1 over x squared natural logarithm of x squared over 3 factorial, like this. But we all know that the natural logarithm of 1 is 0. So we will say the limit as x approaches to 0, we are only having negative 1 over x natural logarithm of x squared over 3 factorial. That's what we are going to have now. So now from there, you'll discover that you will arrive at this point whereby you drop out the x to the squared, and it will be the limit. It will be the limit of x approaches positive, the negative here, 1 over 3 factorial. Remember, I had ln of L, which is now becoming negative limit of x approaches a constant, a number actually. So definitely this number is going to be the limit. Natural logarithm of L is equals to negative 1 over 6. So in other words, your L will be e to the power negative 1 over 6. This is the answer for the limit. Thank you.